Hello, my name is Dave Drone and this is Mobile Application Development. So today we will be introducing Kotlin. It's a very brief overview. It's spread across three parts. The first part, which we'll be looking at, will consist of what is Kotlin, the context, so talk a little bit about Java versus the JVM, talk a little bit about the Kotlin history and some milestones. So in later parts we will cover the general overview and features, the Kotlin and IntelliJ IDE, the environment we'll be working in, and a short conclusion. So, what is Kotlin? It's a fairly new statically typed language from JetBrains. These are guys that created the IntelliJ IDE itself, and that's what we'll be working with. It works very, very well together. It tries to fix many of Java's shortcomings, and a big one there would be the null pointer exception. So any Java developers out there would be very familiar with that one. It compiles to JVM bytecode, JavaScript and Kotlin native. So we're not just restricted to building Android apps with Kotlin, we can use it in a lot of other different types of applications. It's created with a focus on Java interoperability. Kotlin and Java classes can be used together in a project. So we will look at this in more detail in later sections, but suffice to say that we can't mix the code itself, but we can mix the resulting classes that are produced from the code, which is very useful. It's gaining a lot more traction and is being increasingly adopted, especially in the last 12 to 24 months, because of announcements at Google I/O 2017. So we'll come back to that in a minute. And it has very good support from JetBrains, who also use Kotlin themselves to develop their own products, again, that's very useful too. Now, we have a statement from James Gosling, the creator of the Java programming language. This was back in 2011. It's a very interesting one. He says, most people talk about Java, the language, and this may sound odd coming from me, but I could hardly care less. At the core of the Java ecosystem is the JVM. So even though he created the language, he's not too bothered about it really. It's the engine behind it that drives that, and that's what drives Kotlin as well, and as well as other languages, as we see now in a nice little graphic here. Is a JVM language history. We can see there way back in 96 we have a Java, then we have Scala and Groovy, a couple of other ones there, and fairly recent Kotlin slotting in there in 2011. So it hasn't been around that long. Another graphic from posted up on the zeroturnaround.com back in 2014, there December 23rd 2014. It was suggesting that the next big languages to be learning were mainly between Scala and Groovy, and like they were suggesting there Kotlin was 2%, so kind of not really worth bothering about it at all. Little bit of history about Kotlin itself. So back in July 2011, JetBrains started the project Kotlin, which is a new language for that JVM, which has been under development for about a year. JetBrains hopes that the new language itself will drive the sales of its own environment, its IDE. Version 1 of Kotlin was released back in 2016, so again not that long ago. And then in May 2017, Google make an announcement that changes the Kotlin roadmap completely. Again, very big day for Android developers and the Kotlin language, which we will come to now in a minute. Just another graphic there, just trying to highlight the kind of the boom and the upsurge in Kotlin over the last couple of years. We say 2012, 2013, virtually non-existent. Even in 2016, there was only 2.1 million lines of code out there. But as you see there in 2017, massive jump up to 10 million lines of code, and that was all again tied to that the Google announcement. So on the 21st of April 2017, in a DZone article, why you should consider Kotlin for Android development. This is kind of the cliff notes, as they say, but they went on to say Java is the primary and official language for Android development, but that doesn't mean it is the best or the only choice. To give Java credit, it is a robust language that has been around for a while, but it comes with a specific set of challenges that can be a deterrent for developers. Again, massive one there, code verbosity, the null pointer exception. You get a lot of boilerplate code, especially in the Android world, just when you create your very simple, very basic app. To continue, a new breed of modern JVM languages is slowly gaining traction within the Android community, and Kotlin is leading the pack. So that was on, again, April 21st, 2017. On May 17th, at Google I/O, they announced that Kotlin would receive first-class support for Android development. It was a very big day for Android developers, and especially those that were considering moving across to Kotlin but were a bit maybe hesitant and, is it going to catch on or whatever. On the same day, JetBrains posted, for Android developers, Kotlin support is a chance to use a modern and powerful language, helping solve common headaches such as runtime exceptions and, again, to repeat, source code verbosity. That was a big one. Kotlin is easy to get started with and can be gradually introduced into existing projects, which means that your existing skills and technology investments are preserved. So all those Java Android developers out there, they knew that they didn't have to bin all the apps they had built in Java, all the work they had done, all the investments that they had made. They could gradually introduce Kotlin, and Kotlin could run side by side with their Java code, which was great news, really. To continue, starting now, Android 3.0 ships with Kotlin out of the box, meaning Android developers no longer need to install any extras or worry about compatibility. It also means that moving forward, you can rest assured that both JetBrains and Google will be supporting Android development in Kotlin. So again, big day. It meant that the current Android developers, they knew that they were going to have to support now and going forward in the future because of that first class support. So they could just download Android Studio, run it as is, go create an application, choose Kotlin as the language, and not have to worry about, as I say, all those extra plugins and compatibility and all the rest of it. So it was a big day in the Android development world. That kind of wraps up just that small little overview. We'll come back to parts 2 and 3 later on, but for the moment, thank you and goodbye. Hello again, and welcome to the second part of our introduction to Kotlin. In this section, we will be looking at a general overview and some of the features. Okay, so to break it down into the following sections, more or less, we will talk about it runs on a JVM, a Java virtual machine, is an evolution of the Java syntax, but is more concise and has cleaner syntax. Is not syntax compatible with Java, but is interoperable with Java. It relies on some of the Java class libraries like the Java collections frameworks. Is statically typed programming language, and it offers null safety. So the first one we will look at is that it runs on a JVM. And again, we kind of touched on this in the on-site visit, but if you see it there, we have our, just show you there now, we have our Kotlin file through the Kotlin compiler, we have our Java through the Java compiler, both into .class files, so the same bytecodes, so it compiles to the same bytecodes, and that's bundled up into jar files, which is bundled up into an APK, which then is pushed onto the app and onto the device. Okay. So, and Kotlin also compiles to JavaScript, and again, we talked a little bit about that on site as well. The next one is an evolution of the Java syntax, but is more concise and has cleaner syntax. So again, you would have seen a similar kind of family tree here, the JVM language evolution, and you can see we have our Kotlin there right at the end, kind of extending out from Swift and Objective-C and a few other languages there, Scala, Groovy, right back to Smalltalk there. So again, none of these languages really kind of start from scratch. So they generally build on other languages, and Kotlin is built on some of those languages there, as you can see. Kind of point to mention, I suppose, and we'll talk about this quite frequently throughout the module, is that Kotlin is a full OO language. Everything in Kotlin is an object, and again, we will talk about that in due course. To talk a little bit about Kotlin, its conciseness, and Java's verboseness, we had an article here on dzone.com, a few excerpts there from it. Java is extremely verbose and ceremonious. Programmers need to write reams of code to get a simple task done. There's a great deal of ceremony in Java APIs, and Android aggravates this by forcing developers to go through many steps in a specific order to get things done. And again, I can testify to that myself. There's a lot of hoops you have to jump through just to get some basic things up and running. And Kotlin has kind of tackled those issues and solved a lot of those problems. Also, Kotlin provides a well thought out syntax and extensive standard library that removes many of the pain points that exist in Java. And again, I think, as far as I know, most of you would have done Java at some stage. So you'll see the comparisons. You'll see a lot of similarities, which is a good thing, but you will see the differences, which are obviously they're all positives. And again, that's just the source there. You can see at the bottom of the page or up on medium.com there. Rough estimates indicate approximately a 40% cut in the number of lines of code, which is a fair reduction if you think about it. And again, that's on the kotlinlang.org site. And if we want to make a kind of a comparison there, we can look at a simple class. Eamon would have went through a simple program and again compared it with different languages, like again through Groovy and then what it would have looked like in Swift. Here we're just comparing to what it might look like in Java and what it might look like in Kotlin. And in Java, where, for argument's sake, simple example, a class user, and if you remember, kind of the default access modifier in Java is private, which means you would have to, if you have our two fields here, first name, last name, we would have all our setters and all our getters to be able to kind of retrieve those fields and set those fields and so on and so forth. Whereas in Kotlin, because the default access is public, we simply declare two variables here, two fields should I say, first name and last name. We'll talk about that var stuff later on. There's var and there's val. There's subtle differences between them and we will cover those in due course. We specify a type, so we can see there a little full colons, and again we'll talk about those. We'll talk about the question mark later on in this section, and we give them a value of null. That's it. That's what that is equivalent to that. Okay. So Kotlin drastically reduces the amount of boilerplate code you have to write. The less code you write, the fewer mistakes you make, the less the test, the better the execution. Another excerpt from a DZone article. Kotlin is approachable and can be acquired in a few hours by simply reading the language reference. It has a lean and intuitive syntax. Kotlin is also designed to have a gentle learning path for Java developers. Java programmers will find that most of the Kotlin syntax feels familiar. So again, coming from a Java background, you pick it up pretty quick. There's obviously not a lot of new stuff to pick up, but a lot of the basics is the same. And again, you can actually use all the any Java syntax you have if you want, just to get started in a Kotlin project. And over time, you can then maybe factor out some things like simple if statements, while loops, that kind of stuff, and replace that with Kotlin, the Kotlin equivalent, which will be obviously much more concise, a lot less verbose, and ultimately a lot easier to understand. So to talk a little bit about the next point, it is not syntax compatible with Java, but is interoperable with Java. So again, just kind of revisiting how our Kotlin and Java files are compiled. They go through a slightly different process, but they do end up with a .class, which again is bundled up in a jar into your APK, and that's what's pushed onto the device. So that allows for that interoperability. We will see in later sections, in the next section actually, how we can actually mix and match. So we'll cover a little walkthrough of a project and how we can mix and match. But just for the moment, just kind of know that yes, the code itself needs to be kept in separate files. So we need to have our Kotlin code in our .kt file. We need to have our Java code in our Java file. But once it's compiled, they're all compiled into the same bytecodes, which is then, as I said, all bundled up in an APK and dumped onto the device for your app. to talk a little bit more about it, Kotlin and Java are 100% interoperable. Java and Kotlin code can coexist very well in the same project and compile perfectly. And again, we'll see that now in the next section. Kotlin can be called from Java and Java from Kotlin. So really nice feature. You can have your Kotlin class. You can create an instance of so you can create a Kotlin object inside your Java program, and vice versa. You could have a Java class that's already exists, maybe some from some previous project, and you can actually bring that into your Kotlin application, instantiate it, create it, use it, call the methods, whatever they were, as is, no issues, no problems. The next one there, both .java and .kt files are compiled to .class bytecode, which we've kind of talked about already. When a project containing both Java and Kotlin is compiled, it would actually be difficult to tell which parts were created in Java and which were in Kotlin. So if you try to reverse engineer a project, it'd be very hard to spot which was which. You can start using Kotlin in an existing Java project without having to convert the project to Kotlin. So again, talked about this in our on-site visit. There's no need to bin all your Java code. So if you have been tricking around with Android already and you started, and because you would have known Java and you're coming from a Java background, any of that Java code that you have can still be used. You can start integrating your Kotlin code, your Kotlin classes into that existing Java project, and it'll still work fine. That's really nice. Again, a major reason why existing Java Android developers kind of jumped on board with Kotlin, and then the minute Kotlin became or sort of, should I say, JetBrains and Google, should I say, announced at Google I/O 2017 there, as we covered in the last section. Once that got first class support, then it's skyrocketing. It's going to be the de facto language for at least, I'd say, the next 5-10 years. To the next point, it relies on some Java class libraries. So for example, there, the collections framework. You can use any of the vast number of Java libraries and frameworks in a Kotlin project. So if you've done any work at all, having to persist data and having to maybe just store, never mind persist, but even just store data inside a Java application, you would have worked with the collections framework. You would have worked with your array list, your linked list, your stacks, your queues, maps, sets. All those classes are still available to you in Kotlin. Okay, so and we will be working with some of those. Mainly, as I said, the most common ones are array list and a linked list, but any of those Java libraries and those frameworks, they are still available to you in a Kotlin project. So any work you've done previously, it's not kind of for naught, is not lost. You can still actually bring that in. Also, Kotlin can also easily integrate with Maven, Gradle, and other build systems. And again, we'll be seeing that now. We'll be building it up with Gradle in both our JetBrains IDE for just the basic Kotlin console apps, and you'll see it again with your Android apps as well. The next point there is a statically typed programming language. Okay, so we would have covered this also in that on-site visit, but just to talk about it in a little bit more detail and look at some of the examples, just to kind of frame it there first. Variable declarations are mandatory before usage, otherwise it's going to result in a compile time error. Okay, so just to look at some examples here, if we look at our Java, right, we could declare a basic string greeting, give it a value of hello. We might declare an integer here, some random integer, value of and assign it a value of 100, and then declare a double variable with a value of 2.2. So a type is assigned to each variable, and in Java, if we don't assign a type, we get a compiler error as Java is statically typed. And again, just note here, we have a big S for string, which identifies that it is it's a class, as opposed to a small I and a small d, which are basic types. And again, just to mention that again, everything in Kotlin is an object, which means we have our different types determine the operations we can perform on the variables. So here with our string, we could we get the length of it, we can convert it to uppercase to lowercase, because it's a class. It has its properties and it has functionality as well, whereas our basic types don't. And that is different in Kotlin. Everything is an object, so everything in Kotlin will have behavior as well as just its data. Okay. To continue on with this, if we now compare it in our example here, just if we look at our public static void main, okay, or that would be similar to Java, should I say. So in our Kotlin, the equivalent is a function main, right? And here we're declaring two variables, var, we'll talk about that again, var versus val. We're saying some random integer, a value of 100, a double variable, a value of 2.2. We can print them out. In Kotlin, although, you don't have to specify the type of each variable explicitly, right? Even though Kotlin is statically typed, Kotlin determines from the initialization, from the value you assigned it, it can determine what the type is. Okay, so as I said in that example there, we're seeing some random integer gets a value of 100. The Kotlin compiler will know that some random integer is an int class, and then allow you give you access to the behavior and functions that come with the integer class. Likewise with the double, like it's 2.2, anything that we can do with a double variable, a double object in Kotlin, we can do with this variable here. Okay. Now if you want, all right, you don't have to, but you can if you want. You can choose to explicitly define a data type. So again, if we see here, we're declaring our variable, but we're now explicitly saying it is an int type. And here we're explicitly saying it's a double type. Again, note the big I, the big D. So everything in Kotlin is an object. Okay. So again, just kind of worth noting. But again, you don't have to do that. It's totally personal preference. However, just to kind of make note of this, with Kotlin, you have to either define a type or initialize the variable. Kotlin then determines the type. You can't just declare it like so here. So var some random integer and just leave it as it is. You have to either give it a value or specify a type. Okay, one or the other. Or you can do both, as we see in the second example there. We're specifying the double, but you have to, you can't just declare it and decide later on I give it a value. You have to do it in the one declaration. Just something else to note here. Once we have assigned it, again, just a little example here, once we have assigned it as a type int and given it a value, you cannot then go ahead and give it a different value. Okay. And likewise with our double there, was declared as a double, we're trying to assign it an integer, that will result in compile time errors. Okay. The final one there offers null safety. Okay, so again, any Java developers will be familiar with all this stuff. There's a guy here, Tony Hoare. He made a statement there. I call it my $1 billion mistake. It was the invention of the null reference in 1965. So anyone, as again coming from a Java background, will be very familiar with the null value and the null pointer exception. Very hard to track down because they're generally runtime exceptions. So your code, you think you're okay, the code is compiled, you're on the application, all of a sudden getting null pointer exceptions been thrown. You have to go back in, you have to kind of try and debug through it. Can be quite time consuming to try and do all that, hence the $1 billion mistake. And even trying to check for it and your defensive programming to try and ensure that something may or may not be null, and if it is happened to be null, to be able to deal with it. Okay, so that was all extra overhead when developing in Java, but Kotlin actually deals with that. So Kotlin eliminates most sources of null references by making all types non-nullable by default, meaning that the compiler won't let you use non-initialized, non-nullable variables. If you need a variable to hold a null value, right, you have to declare the type as nullable by adding a question mark. If you can remember, we saw that previously in some of the previous slides. you declare the types as nullable by adding a question mark after the type. Now we will be looking at this in a lot more detail later on, but just to highlight it here just for the second, we have our var non-nullable, so we're declaring it, explicitly saying it's a string, and we're giving it a value. Okay, so that needs to be initialized. However, we can say something like this. We can say var nullable, declared as a string, and we append the question mark, which tells the compiler that this is allowed to hold a null value. And there will be situations where that is the case, we need that flexibility as developers to be able to do that, and Kotlin gives us that flexibility with that simple question mark. Okay, we will be looking at examples of that later on. We will see it in our own code, both in the console app placemark case study that we're going to do with myself, and the placemark Android app that you will be seeing with AIM. But for the moment, just kind of know that if you need your Kotlin variable to potentially hold a null value, that's what you do. You can just declare it with the or append the question mark at the end. That kind of wraps up that section for our part 2. Okay, so like I say, in part 3 we will be looking at a kind of a little walk through the IntelliJ IDE that we'll be using for our Kotlin console apps, and some little examples of how we can compare, or we can mix and match, should I say, Java and Kotlin classes. Okay, so thanks and goodbye. Hello again, and welcome to the third part of our introduction to Kotlin. And this is we're still looking at kind of a general overview. So this is our part 3. So if we just quickly look at what we've covered again. So we've gone through what is Kotlin, the context, a bit of history, some milestones, general overview and features. And today in this section, I just want to cover the Kotlin and the IntelliJ IDE. So what a new project will look like when we set it up using IntelliJ, and make sure you have the educational version downloaded, and then we'll just finish off with a quick conclusion. Okay, so as I say, we're using the educational version, so hopefully you have that downloaded and installed correctly. But if there was any issues, if you have any issues, please contact me, and we can try and troubleshoot that and fix them for you. Okay, so when we go and create a new project, so this is the screen you're going to be presented with, the first one. Again, just to highlight some of the features, this at the moment, it's still the 2020 version, it's the version 3.4. May have been updated. This is the most recent one that I would have downloaded, but again, they do tend to change these quite quickly. So just kind of make note of that number. So you can see on the left hand side, we have a couple of options. What we're focusing on at the moment would be a new project or open a project. So for us, when we go to do our first lab, create our first application, work through the examples, we'll be selecting a new project. Okay, so when we would select a new project, we get something like this. Okay, so again, you can see with the IDE, there's a lot of different options you have. Okay, so you can see there defaults to kind of the Java version, but if you can see there, look, we have you can do Java FX, maybe you've done that somewhere yourself, even your Android, Kotlin, that's kind of what we'll be focusing on as well. You can even build some web or Scala projects, excuse me, even a plugin if you wanted. Okay, but what we're going to be focusing on will be a Gradle kind of setup, and we'll cover that now in a minute. But just one other point to note, that if you don't have, as I had here just to show the example, if there's no SDK selected, okay, and this may happen the first time you run it, IntelliJ will detect the SDKs that you have installed. So because you've done programming fundamentals already, you should have a JDK installed. So we should pick up one of those versions. Now, if for some reason you don't have it, maybe this is a new machine you're installing it on or whatever, you would need to go and download that particular JDK. But initially anyway, you only have to do it the once. Just select a particular JVM and a JDK, and that will then be used to build and tie into your application. Okay, so then once you've selected that, okay, we're going to have something like this. So we go into our, once we've selected our version, so we can see it here we're looking at 1.8. Okay, so what we want is we want to choose the Gradle, and we want to make sure that it is a Java and Kotlin JVM compliant project. So there are the particular libraries and frameworks we want to add. Again, you can see you could do one in Groovy, you could do a JavaScript one, you could do one for kind of a back end if it's going to be for Node.js. But we're going for this particular module, we're going to focus on Kotlin and Java. And again, we'll come back to that now in later parts of the slides, just making a comparison between the two. Okay, so once that's done, you click on next, and we get something like this. So we're just we're being asked now for some kind of metadata about our project. The most important ones for us will be the name and the location. The rest, under your artifact coordinates, you may have to expand it. You don't have to change them. It's mainly just for if you're going to be deploying your application, or if it's on a multi-person project or whatever. So we want to just, in this example here, we're calling it types. And for my particular location, it's just got have it in my downloads folder. But I would suggest for you something like what I've done here. I've created a subfolder in my downloads folder calling it Kotlin apps, and then inside that, that's what I want my location to be. So if we notice that, make sure that the name of the name of the project maps to the location, so that it will be easily located and found at a later date. Okay, when we click on finish, so that's basically the setup, right? The IntelliJ will go off and start building your application, start downloading any libraries it needs, and you will end up with something like this. Okay, so if we just look at this for a second, right, what's open at the moment is this build.gradle. So the reason I have this open, and this is where, not for the first lab, but for subsequent labs, this is where if we want to add in any extra dependencies and any extra libraries, that's where we can specify. So at the moment, this is just including or linking to the Kotlin standard library. So that's kind of most of the kind of the standard libraries that you need. Okay, but it's also got some other details about your application here, the particular plugins, the version of Kotlin that it's using. So again, that number might be a little bit different, and even as for testing, some other kind of function there that it's going to run. So we only ever probably need to work with this and change this particular section is if we need to add in some new dependencies, and that's something that I will cover with you in later labs. But in terms of the project that we get, so in our project window, so this is our full project for the moment. So you can see there's a couple of different folders. The main one for us will be the source folder. So by default, we have this main and this kind of test. Okay, so this is where we're going to add in our own particular code and our classes and files for that matter. If we need to go back to our build.gradle, that's this file here. So in terms of configuration of our application, that's where we would change it. But this is what's built up by default. So at this point, we can then go ahead and start writing some code, adding in classes, adding in files, whatever we need to build our application. Okay, so if we go on again, so in our example here, inside our main, if you expand your main, right, that will be split into two folders, your Java and your Kotlin. Again, which it kind of identifies the fact that we can mix and match Kotlin and Java in the same project, not in the same file. That's very important, have to be kept in separate files. Hence, we have two separate folders, Java and Kotlin, but they can be shared and used within the same application. And again, we will cover some of that now in the remainder of this this video. Okay, so initially what we want to do is, and generally we will do this for all our versions of our placemark, our case study, or in your assignment, you can right mouse button on a particular folder. So here we get another menu, another context menu. So we're going to go new, and here's all the different types of files and classes and objects, I suppose, we can create. Okay, so what we're looking at for the moment is a new package. So we would select our package and we'll be prompted then for a particular name. Okay, or we can choose when we're finished, we would then create a Kotlin file or class. Just highlight that again for you. Okay, so now for the first few instances, it will be a Kotlin class/file we want to store inside our particular package. Okay, so if we go on to just go on to the next slide there again. Okay, so what we have here we're saying we want to give it a name. So we're going to call it main, right? But in terms of, just fix my pointer there now. So we're going to call it main, okay? But to begin with, we want it to be a file. We're only going to store some code inside our Kotlin class. Remember, this is a big difference with Java. With Java, everything is a class. That's not necessarily the case with Kotlin. We can have kind of standalone blocks of code in separate files. So that's what we want to do now. So initially, for the first few labs, it's files we will be working with. So just make sure that it's a file you select and not a class. Okay, so we would select our file, go on to our next slide, and what we get is, so here what we've done is we've created a package called org.with.types, and inside that package we've created a new file. That's important, a new file called main, and then the .kt is appended automatically. And then we have pasted in here, it's very simple, function main, very similar to your public static void main from Kotlin. And we have a couple of printlns. We can just say print out to the console, hello world, working with variables and types. And if you notice, I'm just highlighting this here. If you know, for our initial run, the easiest way to run the application is to select our play button here in the left hand column there, along with the lines. Okay, so once that's done, once you've run the program at least once, you will then have a couple of other different options to run your application. But to begin with, this is the easiest way to run the application. Okay, so we have it inside a package, and it's a simple function inside a simple file. No mention of a class. No, we're not calling any member operators or whatever. Okay, so that would run the application. Now, in terms of how it looks in the bigger picture, this is what we would have. So here's our package again. It's inside our Kotlin because it's Kotlin code we're dealing with. There's our main, and here's here's the main file itself. There's that play button. But also now, once we've run it initially, we can then run it from up here as well if we want to. So we can use this option to build it or compile it. We can then use this option to run it. Okay, to run our application on the console. Now, just highlighting it again there for you, just showing you that we have our package and our main.kt, and then finally just the source code that we need for this very, very basic program, our hello world program, with a little bit more, just a println saying working with variables and types. Okay. Now to talk a little bit about interoperability, and I would have mentioned this previously, and this can be very useful. So this is a slightly different project. Okay. But so what we have here is here's our Kotlin, and again we have in a different package, com.with.hello, and again .main.kt. Okay, so that's the reference is a little bit different, but it's in our package called hello world, and it's our main.kt. It's just a different view we're looking at, right? And we have our customer.java, which is in our Java folder. Okay, so if we look at this is something you're familiar with, our public class customer. We have a private field name, we have a constructor, we have some setters, set name, we have a getter, get name, which returns the name, and then we have a toString. So we're overriding the default toString to format how a customer object would be displayed to the console. Okay, But if you notice down here, we have, look, there's hello world getting printed, and then we have a customer getting printed to the screen. Okay, so if we actually look at our main, so to speak, right, how we use that. So we're just showing you the class first, which, remember that this is a Java class. Okay, and then in our main, we have a function. There's our function main. We print in hello world, but we use the Java class customer. Even though this is a Java class, we construct it in Kotlin code. So we declare a variable called customer, create it like it's and use it like it's a Kotlin class. Okay, and then print that object out to the console, and that's what we get down here. So this is a simple example of how we can mix and match both Java code, which was in our customer class, and the Kotlin code, which is our function main. Okay, so what we're trying to, I suppose, point out here is that you can reuse Java code if you need to. So if you're converting from Java to Kotlin, you don't have to do it all in the one go. You can do it in stages, and you can bring over individual classes, individual code bases, piece by piece. The only requirement is that you keep all your Java in a Java folder, and you keep all your Kotlin in the Kotlin folder. Okay. So just to compare then Java and Kotlin, again, a kind of interoperability, but also the reduction in the code base. Okay, so if we look at our customer class again, okay, here it is in Java. So here we are. We have our functions, our toString. We have our setters and our getters. Okay, the same class with the same functionality in Kotlin will be reduced to this. So we just say our var name. We have, there's our init. So when the class is created, that init function is triggered, the init call. So we just assign the name, and then we have a toString. So you can see yourself there that the Kotlin is a lot more refined, is a lot less verbose. So there's not, we get the same job done with a lot less lines of code. So that, from a developer's point of view, that can only be a good thing. Okay. So to wrap up, just a small little conclusion. So Kotlin, it's low cost, can be developed in the same IDE, in the same project as Java code. So that can be a really popular and a good advantage for Java developers, and even more so in the Android world. And that's something that we might look at later on and talk a little bit about later on. Okay. It's becoming one of the leading JVM languages because it's very fast. Okay, it's best suited to work with the IntelliJ IDEA because the same guys who developed IntelliJ have developed Kotlin. And if you want, you can say it's kind of cool, allows bragging rights to friends about using the latest tools and technologies. So you might have other friends in other colleges that may still be doing Java, and you can say now that you're doing Kotlin. Okay, so other than that, I think that kind of wraps up the overall overview section and kind of a high level look at Kotlin. So what we will begin now in the remainder of all the sections is looking at Kotlin in a lot more detail. Okay, so thanks for listening, and I'll talk to you soon. Hi all, so this is just a short little video on where to find IntelliJ and how to download it, and download the particular version that we will be using for the module. Okay, so the first thing you do is, if you open up your browser and visit jetbrains.com, you can see it up there, just highlighting it for you there now. So jetbrains.com. Okay, that'll take you to their homepage. Okay, and if you go up to developer tools and down to the IntelliJ IDEA, so that's the one we want. If you click on that, that will take you to this page, their particular download page. And again, if you just click on download, it takes you to all the different versions that you can find and you can download. Now, because I'm recording on a Mac here at the moment, that's why it's defaulting to a Mac, right, or .dmg. But as you can see there now, you can change the different versions, right? So on your particular machine, so if you go to Windows, you can see it there. You can pull down .exe, an archive if you want, or the executable, and likewise version for Linux as well. Okay, so for me, obviously it's picking up the Mac OS. Okay, but what we want is, if we scroll down, right, and this is because this is the free version, so we want to download the educational version. So the option there, try learning or teaching programming. So that's what we're doing. Okay, so if you literally just select that, it'll go off, and for me, you can see it up in the corner there, just downloading the IDE, my executable, so you can see it there. And again, if you notice, it is kind of big, so you might want to give yourself some time to get this downloaded. So what I would ask you is just if you could have this installed before the first lab, that would be great. Okay, and in the labs, I will take you through how to use this, how to create our first project, how to set it up, and we will follow the lab step by step as well. Okay, so that's just how to this little video there just shows you how to find and download the IDE that we need for the module. Okay, so thanks for listening, and goodbye.